Okay, so by now you should have read your book and filled in these notes. So I just want to go over some of the pieces that maybe you didn't get when you're looking at the book. So if you need to, you can pause this video to copy anything down. I'm just going to try to go through it kind of quickly. You should have got your definitions for experiment, event, simple event, and sample space. And then for some examples, you may have gotten this from the book already, but here's some more examples. So an experiment would be tossing a coin. Your sample space would be heads or tails. Those are my outcomes. And an event would be tails. Another event would obviously be heads. If I roll a die, I get 6 possible outcomes. So this is my sample space. And the way I'm writing the sample space is with these squiggly brackets. So there's 6 values in that sample space. And if I look at the number 2, just rolling a 2 on that die, that would be considered a simple event. If I roll 2 dice, and when you roll 2 dice, you actually have 36 outcomes. That first die can have 6 outcomes. The second die has 6 outcomes. So in total, you have 36 outcomes, 6 times 6. So I've got 36 outcomes. So I could have a 1-1, a 1-2, a 1-3, and so on. So I have 36 of those. I'm not going to write them all. I just use that ... there. And if I consider the event 7, that is not simple. So the reason why it would not be simple is because I can get a 7 by rolling a 2 and a 5 and a 2, a 3 and a 4 and a 3. So there's multiple ways I can get a 7. So that is not a simple event. So that leads me just into a discussion here about simple events versus compound events. The compound events are ones that are not simple. So simple events include only one outcome. So example, if I just roll the 5 on one die. Compound events include 2 or more simple events. So as an example, if I roll a 7, so I could get a 1 and a 6, a 2 and a 5, and so on. However, if I talked about the event 1-6, so 1 being on the first die, 6 being on the second die, that would be considered a simple event because I'm specifically saying I want 1 on the first die and 6 on the second die. You should have gotten the notation already in the book. Here's some things that you may have not gotten from the book. So the probability of impossible event is 0. So the probability that you will not have homework this evening, that is 0. The probability of an event that is certain to occur is 1. So the probability that you will have lots of notes is 1. And probabilities are always between 0 and 1, including 0 and 1. So each individual probability is always between those numbers, or you could say between 0 and 100%. Here's a little bit of information about how to write your probabilities. I usually use fractions when they're easy to interpret, so simple fractions. Otherwise, I would write them as decimals. Then you should have read about the 3 different approaches when you were looking over those notes. You should have filled in this. The only thing that you might have not have filled in is some examples. But just before I get to that example, this relative frequency approach, this is just kind of like when you're doing an experiment, so you're looking at that. And this law of large numbers is kind of important. So as an experiment is repeated a large number of times, the relative frequency approaches the actual probability. So what this means is if we look at an example here, so if you think about tossing a coin, and if I toss a coin, let's just toss it one time, you can see I got a head there, so I have 1 head. So if I keep tossing that, so the next time I got a tail, so now I'm at 1/2. So if I only did this experiment up to 10 tosses, I'm not quite exactly at 50% heads. I only am at 40% heads, 60% tails. But what the law of large numbers says is if I repeat this experiment and toss this coin several more times, as I repeat that toss, that experimental probability or the relative frequency probability should approach the actual probability, which is 0.5. So it's getting closer to that. Actually, it's still at 60-40, but if I tossed it again, it'll still keep getting closer. And as you can see, it looks like my coin here is a little bit more biased towards head, even though it says the probability head is supposed to be 0.5. But hopefully you actually do believe me that if I keep tossing this coin, I should get closer to that 50%. And just for the sake of resetting my experiment, here's another one. Of course, now I'm going in the opposite direction. But anyways, if I look at this one here, this is an example with rolling a die. And when I roll this die here, the average, so if I roll a die and it just marks out which number I get, the average of those numbers, it should be 3.5. So if I roll more die, it's going to get closer to that 3.5. And this one seems to work a little bit better. But hopefully you get the idea. So that's all the law of large numbers is. It's just saying the more you roll something, or the more you repeat something, it gets closer to the actual probability. For your theoretical probability or classical approach, this is just kind of more what you're used to, just thinking about it. So your probability of heads, that would be 1/2. The probability of getting a 6 in a die would be 1/6. Subjective is just merely subjective, so it's just like you're guessing. So the probability that you will get hit by a meteor on your way home. There's no information that we can collect about that. We just have to make a guess, and I would guess that'd be very close to 0. All right, this page you may have not done. You really don't want to just copy this if you haven't done it yet. You want to actually kind of try to figure these out. I'll leave these answers here for a second. The only one I think you might get stuck on would be number 3. And for number 3, you're having 2 girls out of 3 children, and the order does matter. So having a boy first and then 2 girls versus having a girl first and then a boy and then a girl, that is different. Those are different sequences. The order is important here. So I actually have 8 combinations. I have 2 times 2 times 2, which is 8. Here's your answers. So then I have 8 combinations. When I list all those combinations, out of those combinations, I see that there's 3 that have exactly 2 girls. So I just have 3 8s. And there's the answers for the bottom parts. And like I said, hopefully you're not just copying these answers. Hopefully you're actually looking at them and understanding them. So you have no questions on this. If you don't know your deck of cards, I have some. You don't have to worry about that. I usually will help you out with that. All right, complementary events. You may not have gotten this example. This was just an example of complementary events. If you were to draw a Venn diagram, complementary events, they would have no overlap, and therefore they are always mutually exclusive. So they cannot occur at the same time. The formula was there. If you have the probability of A plus the probability of A complement, that's supposed to be equal to 1. If I use some algebra to solve that, I have the probability of A is equal to 1 minus the probability of A complement, or the probability of A complement is equal to 1 minus the probability of A. So I can switch that, rearrange that. There's 2 examples here, which you may have done, and those are the answers for those ones. And then finally on the back page here about odds, hopefully you got some of this stuff. Just some things to note here. You want to always reduce your odds. And you can write those odds with that colon. You don't have to write them as a fraction. Again, you should have gotten all these definitions. Just note here the number of favorable plus the number of unfavorable should equal your total number. Your payoff odds, in case you didn't get this in the reading, ratio of the net profit to amount bet. So basically it's just the net profit to the amount bet and written in colon notation. An example, if I bet $5 and 130, my payoff odds would be 25 to $5. So I bet 5, I win 30, so my net profit is 25. The amount I bet was 5. When I reduce that, I get 5 to 1. Here's some examples right here. If you want to take a minute and just go through those. So 3 red golf balls, 5 blue, 2 white. So find these probabilities or these odds. Go ahead and do that. Pause this video. Don't just copy my answers. And the answers that you should have gotten are going to be listed right here in this purple post-it note. And then your homework assignment is right here. It will also be posted on Edline. So if you guys have any questions on this, you can ask me tomorrow, but you should have been able to fill this out with the book in addition to this video.